Hello students, in this video we are going to discuss 4.5, 4.6 and 4.7 from laws of motion. 4.5. A constant retarding force of 50 Newton is applied to a body of mass 20 kg moving initially with a speed of 15 meters per second. How long does the body take to stop? Here he has mentioned a constant retarding force. That means the force which causes the retardation. Here F is equal to minus 50 Newton I am taking because of retarding force. And the mass of the body is given as 20 kilogram. And the initial velocity of the body is 15 meters per second. And the final velocity of the body will be 0. Now we need to find out the time taken. How much time do we take its velocity from 15 meters per second to 0. Now we can write acceleration is equal to force per mass. That is minus 50 divided by 20, that is minus 2.5 meter per second square. Acceleration is equal to minus 2.5 meter per second square, or you can write retardation is equal to 2.5 meter per second square. Now we can use the first equation of motion, V is equal to U plus AT. From this we can calculate time value. V is 0 and U is 15 and A value is nothing but minus 2.5 into T. From this we can write 2.5 T is equal to 15, and from this T is equal to 15 divided by 2.5, we will get 6 seconds. So it will take 6 seconds for a body to come to rest because of the retarding force. (4.6) A constant force acting on a body of mass 3 kg changes its speed from 2 meters per second to 3.5 meters per second in 25 seconds. The direction of the motion of the body remains unchanged. What is the magnitude and direction of the net force? Here the given values are m is equal to 3 kg and initial speed 2 meters per second, final speed 3.5 meters per second. The time taken is 25 seconds. Now force we need to find out. Before that, coming to acceleration, A is equal to V minus U by T. That is 3.5 minus 2 divided by 25. That is equal to, you will get after simplification 0.06 meter per second square. Then the magnitude of the force F is equal to MA and 3 into 0.06, nothing but 0.18 Newton. Here the speed of the body is increased. That means the force is acting in the same direction of the motion of the body. So while coming to the direction, we can write it is nothing but the force acts in the direction of motion of the body. That's why the speed of the body is increased. Coming to 4.7. A body of mass 5 kg is acted upon by two perpendicular forces 8 Newton and 6 Newton. Give the magnitude and direction of the acceleration. Suppose say this is a body and on this body one force is acting horizontally. Assume that there is F1 is equal to 8 Newton and one more force is acting vertically. It is F2, that is 6 Newton. He mentioned 8 and 6 Newton, both are perpendicular. So their resultant will be here. The F net value will be here. So therefore, if you are taking F1 is equal to 8 Newton, F2 is equal to 6 Newton and mass of the body is given as 5 kilogram, F net, the net force is equal to F1 square plus F2 square because these two are perpendicular to each other. That is equal to 8 square plus 6 square. We can write it is 64 plus 36, 10 Newton. Okay, we need to find out the magnitude and direction of the acceleration. We know that acceleration A is equal to force per mass, that is net force is number 10 divided by 5, that is equal to 2 meter per second square. This is the magnitude of the acceleration. While coming to the direction, assume that if F net is making an angle theta with F1, we can write cos theta is equal to adjacent side is nothing but F1 by F net, that is 8 divided by 10, 0.8. If cos theta is equal to 0.8, theta is equal to cos inverse of 0.8. This is the answer. Further, if you use natural cosine, we can get the value 36.87 degrees. Here, this 36.87 degrees with 8 Newton force. We can use sin theta or cosine theta or tan theta. Choice is yours. This is the magnitude of the acceleration 2 meter per second square and the direction of acceleration. Thank you.